Now I will, for the next couple of minutes, I will talk you through our technology in more detail. My name is Torbjörn Lindquist and I operate as the CTO at Azelio. And I've been involved in this project from the very start. So I have quite a lot of insight into it, and that's what I want to share with you now. So before talking about the details, I mean, I'm so happy that for the introduction from Julia to set the scene, why this is important and what's the drivers behind the technology specification that we set out a few years ago. It's not, I can't reiterate enough to say the importance of this technology, long duration energy storage, because it is the enabler to grow the installed capacity of wind and solar. So if you want to do that, you need energy storage. But that is not new. As we've seen in the graphs before, there are other technologies. I mean, the long duration energy storage council has maybe 50 or more different companies developing this technology. And I will tell you what differs ours from some of the other ones. Pumped hydro, for example, has been there for many, many years. And it's by far the greatest installed capacity worldwide. The downside is, though, it takes time to build, and you can't build it everywhere. And we want to deploy technology close to customers all across the world. And that's where we started developing our technology. Batteries, as Jonas said, we can deploy them today. They work fine, few hours here and there, and it's a fantastic technology. But it doesn't cover the 24/7 solution that we have developed. And when I say 24/7, I mean renewables, daytime, and some of that renewable that we produce daytime, we store in our thermal energy storage, and we deliver that to customers at night or even during the day when they have a need for that. I said thermal energy storage. We are in that sector. So we use a thermal storage, not battery, not chemistry, not pumping water. We melt aluminium or aluminium alloy with silicon at around 600 degrees C. That's a perfect system to power our heritage, and our heritage is a Stirling engine, and that's what we have as an own IP technology to convert heat to electricity. And not just only electricity, we also use that to produce heat. But I will come into that a little bit more later. What we sell to the customer is really a cluster with its own control system. So it responds to demand. The customer does not see really what's inside that cluster, but I can talk, that consists of several units. So each unit we call test pod, and the cluster could comprise of 20 units, 40 units, and so on, depending on how much power the customer needs. Each unit in that cluster is a Stirling engine that can provide 13 kilowatts of power. And on top of that, we have something like 25 kilowatts of thermal energy at temperatures below 60 degrees C. So that's what you get from each unit. So if you have 20 units, you will get 250 kilowatts of power, and you will get up to around 500 kilowatts of thermal energy. That's what you have available in that unit. When you do these designs for a customer, when we get a request from a customer, so we then say we size a PV field, and we size a cluster or a number of different test pod units to match the customer demand. In this modeling, we take into account, are we connected to the grid? Are we off grid, behind the meter, in front of the meter? Do we need gensets? How strong is the grid connection? How much power can we actually transfer there? And the main objective, are we going to design it to minimize the fuel burn, or are we going to design it to minimize electricity to the grid? So having all of those components, then we can design the system. And by far, the most important component in this system, even if you have gensets and batteries to complement, by far the most important thing is the thermal energy storage system that we call the test pod. So this is a unique solution as Jonas said previously, there's no other solution that can provide a 24/7 completely renewable system to a customer. So charge daytime with renewables, discharge nighttime to provide the customer with electricity. And it's scalable. Each unit, 13 kilowatts in clusters, and that's how it's connected. It's modular, it's efficient, and it provides very low cost of electricity. In that system that we have chosen materials that are environmentally friendly and abundant. So we've chosen silica, aluminium, and the heat transfer media that we have with connecting the storage with the engine is sodium. And there's plenty of sodium, but of course that's sodium chloride, it's a salt, but without the chloride component. So there's plenty of that, and it's all environmentally friendly. And that has been a key driver for us when designing this. No hazardous and no scarce materials that you have to find in mines worldwide. Other things that are good with this design is that we don't need any cooling devices. We don't need cooling towers, cooling water, and we definitely don't need to control the temperature in the system, which you may find in other technologies. And because of the reason that we don't need cooling water, the engine needs cooling, but we normally do that with ambient air. So ambient air is cooling the engine because it's a thermal engine. As thermal engine operates, you provide heat and you extract heat, and that's cooling. And that's what I want to focus on now. That's the heat we can provide to customer. And depending on the customer's heat demand, he or she could be interested in heating up a pond for fish production. Then we're looking at fairly low temperatures that the customer is interested in. We can do that. The engine automatically adapts to that temperature. If we want to produce desalinated water, the temperature goes up because the temperature goes up to maybe 60-65 degrees C. The engine adapts to that. So the temperature range between low and high temperatures, that's automatically controlled and set by the unit itself. And that's a huge advantage, and there are many applications where this relatively low temperature range is highly sought after worldwide. Many applications, as we will hear from speakers later on in this pitch. So the technology we have put in place, it is operating. Last year we validated performance, we validated its functionality, and we got that signed off by a third-party D&V. Currently we are operating a number of units worldwide to collect data to show its lifetime operation. How does it work on a longer time span? And that's ongoing work now. And we are confident that we will deliver this technology to customers, and we recognize that we've had technical issues, but all companies who develop new products and revolutionary products do face that, but we have an excellent engineering team behind us who have dealt with these issues, and now we have a product that we feel confident will be put in the market, and hopefully the sales will take up as well. So I think that concludes a very brief technical insight into our product with supplying electricity nighttime and as well as heat. So thank you very much for listening.